This is Chapter 10, IP Fundamentals. The IP protocol was developed by the Department of Defense. It was specifically designed for communication over the Internet. The IP address was the solution to identifying network nodes on the Internet and was approved in 1980. An IPv4 address consists of 4 octets. An octet is an 8-bit or 1 byte value. Each octet in an IPv4 address is composed of 8 digits of zeros and ones. Periods separate each octet from neighboring octets. They are interpreted and used in the decimal form. When an octet is interpreted as a decimal number, the values range from 0 through 255. This range is based on the maximum possibilities of an 8-position binary number. If you fill in all 8 bits with ones and add up and convert to decimal, it is the number 255. IPv4 addressing is a method of identifying every node or host on a network. And we do use those two words interchangeably. Node and host are devices on a network. The terms host and node identify PCs, printers, network equipment, anything that has an IP address. An IPv4 address has 2 parts, the network number and the host number. The network number identifies the network you're trying to connect to, and the host number identifies the host or node that you are talking about specifically. For the purpose of assigning IPv4 addresses, networks are divided or were divided into 3 major classifications: Class A, Class B, and Class C. There are also a Class D and a Class E. I believe Class D is educational research and E is multicasting. Large networks are assigned a Class A classification. A Class A network can support up to 16 million hosts on each of 127 networks. Medium-sized networks are assigned a Class B classification. Class B network can support up to 65,000 hosts on 16,000 networks. Small networks are assigned a Class C classification. Class C network supports 254 hosts on each of about 2 million networks. The range for a Class A network is from 1 to 127. For a Class B network is from 128 to 191, and for a Class C network, it ranges from 192 to 223. A network can be divided into smaller networks. A network within a network is known as a subnetwork or subnet. A subnet mask is a number that's similar to an IP address, again, 4 octets separated by decimals. It is used to determine in which subnetwork a particular IPv4 address belongs. The subnet mask can be used to identify the class of a network, but it is really intended to allow the network address to be broken down into subnets. When the subnet mask is encountered, it's usually viewed in the decimal form, a series of 4 3-digit numbers. At first glance, a subnet mask may appear identical to an IPv4 address. However, a subnet mask is distinguishable from an IP address because it begins with 1 or more octets of 255. An IPv4 address cannot begin with 255. The octets of a subnet mask correspond to the octets in the IPv4 address. The numbers found in a subnet mask depend on the class of the network and the number of subnetworks into which the network is divided. The subnet mask is combined with the IPv4 address using the bitwise AND operation. That's a logical AND operation. And the resulting address identifies the subnet ID or the network ID or the subnet address. When they created the IP networking, they reserved a number of IPv4 addresses. 3 of these ranges of addresses are reserved for private networks. They are not valid for use as a direct connection to the Internet. In fact, the Internet cannot route these addresses. It doesn't know how. For Class A, the private network ID is 10, and that ranges from 10.0.0.0 through 10.255.255.255. And the subnet mask is simply 255.0.0.0, which is a Class A subnet mask. The Class B private network reservation addresses are 172.16.0.0 through 172.31.255.255. The subnet mask for Class B is 255.255.0.0. The reserved addresses in Class C for private networks are 192.168.0.0 through 192.168.255.255, and the subnet mask for all Class Cs is 255.255.255.0. The Network Address Translation Protocol can translate private network addresses into an assigned internet routable address and vice versa. NAT was especially designed for implementing private network configurations. It's important to note that a private network such as an intranet, may use any possible IP address as long as it does not connect to the internet. Using a number that is assigned to a URL would not only confuse the network system, it is actually illegal. The reserved private addresses can be used even when the network connects to the internet, because the internet does not recognize the private network addresses and it does not affect the system. This is why private network addresses are ideal for creating subnets. Windows XP and later use the ipconfig command issued from the command prompt to run the IP configuration utility. The assigned IPv4 address, the subnet mask, and the default gateway address are displayed. To reveal more information about the connection, you can use ipconfig/all. Notice that this also will list the /all will also list the MAC address, the DHCP server address, and a DNS server, and some other information. Since IP addresses are difficult to remember, the internet uses a domain name system, DNS, to make it easier for people to identify and find networks on the internet, such as Google.com. It gives it a name, which is called a domain name, which is associated with a network address. You can communicate on the internet by using a domain name or an IP address. The IP address connects faster to a distant location than a domain name because a domain name has to be converted to an IP address before communication can begin. This means that IP addresses are actually what we use to communicate. Even if you type in google.com, it actually looks that up, resolves it to an IP address, and then goes to that address. The Internet Corporation for Assigned Names and Numbers, also called ICANN, is a private, not-for-profit organization that coordinates the assignment of domain names and IP addresses. It does so by allocating domain name registration to select private companies. Each of the select private companies is called a registrar. Read that as GoDaddy, for instance. To obtain a domain name and an IP address, a business or organization places an application through a registrar. Once the registrar processes the application, the business or organization receives an official second-level domain name and an IP address that is registered to that domain name they have been issued. To locate a host on a large network, you need to use the complete name of the host, which includes a combination of the host name and domain name. The complete name of the host is referred to as the fully qualified domain name, or the FQDN. Therefore, www.google.com is different than mail.google.com. Yes, domain name service is hierarchical. In other words, it's kind of a tree. At the top of the DNS is the root. It is represented by an invisible dot before everything else, like www.google.com. Directly under the root are top-level domains. The most common top-level domains are .com, .edu, .gov, .int, .mil, .net, and .org. The next level of the structure, they have added some top-level domains, by the way. The next level of the structure is composed of second-level domains. Second-level domains represent the domain names as assigned by ICANN. Second-level domains identify various companies and organizations. The structure is then further divided into subdomains controlled by the second-level domains. A subdomain is any level domain located beneath the secondary domain. So mail.google.com. The top level domain is .com. The second level domain is Google, and the subdomain is mail. The DNS root servers are located at the top of the domain name hierarchy structure. The root domain servers store the ultimate database for resolving an internet domain name to a specific IP address. Currently, there are 13 DNS root servers. A top-level domain server stores DNS information for all the top-level domains. A second-level domain server stores DNS information for all second-level domains. Now, DNS operation begins when a resolver requests that a domain name be resolved to an IP address. The resolver is a software program located on a host that queries a DNS server to resolve a host name to an IP address. The first DNS server the resolver contacts is a subdomain server. A subdomain server may be queried for the same information many times because the request is likely to occur again from a different host. In other words, everyone's looking for google.com. Domain names are placed in a cache on the domain server for future requests. If the IP address for the domain name is not in this cache, the domain server then queries higher level domain servers until it reaches the root. When the information is found, it is returned to the resolver. The resolver will then connect to the intended host. The domain service is dynamically changing all the time. It's like a live entity that continues to grow and update with new information and changes. Every time someone requests a new domain name, it's added to that information. During the update period, errors that can be encountered while trying to resolve a domain name to an IP address. Most servers will cache domain name information for about 3 days. The network administrator controls the time period. If a domain changes its IP address during the 3-day period, an error can be generated attempting to connect to the domain site. This is because the old information about IP address is still in the server cache and has not been updated. Let's talk about the OSI model again and TCP/IP protocols. TCP/IP is actually a suite of protocols. The 3 most commonly used protocols in TCP/IP are obviously IP, TCP, and User Datagram Protocol, which is UDP. IP is assigned to control data transmission between 2 nodes and ensure that a link has been established between source and destination. IP does not care if the packet is delivered correctly. IP simply transmits data. IP, therefore, is a connectionless protocol. UDP functions similar to IP. It establishes a link but does not ensure that data is delivered correctly. It is also a connectionless protocol. The main difference between TCP and UDP is that TCP is a connection-oriented protocol, and therefore it ensures packets arrive intact in the correct order. The main difference, I already said that. Wow, I have it twice in my notes. TCP breaks large amounts of data into smaller packets, and UDP does not. UDP sends a single packet to transmit control information and data. The top 3 layers of the OSI model, application, presentation, and session, take raw data and send it down to the transport layer. At the transport layer, large blocks of raw data are broken into smaller units referred to as segments. Segments are placed into data portion of the TCP or UDP frame. The selection of TCP or UDP frame depends on 3 factors: what the software wants, the amount of data that's to be sent, and whether or not it needs to be connection-oriented or connectionless. Both the TCP and UDP frame formats provide the port number of the source and destination. For UDP, the port number is optional, but for TCP, a port number is required. The content of the TCP or UDP protocol is then moved to the network layer. At the network layer, the TCP or UDP frame is enclosed in an IP protocol frame. The entire unit is referred to then as a packet. The IP packet contains a source destination IP address and is sent to the data link layer. The data link layer performs the final encapsulation of the combined frame formats. The data link layer supplies the physical address of the destination and source. Physical address is the MAC address. Then the collective unit of frame is referred to as a frame. The frame is placed on the physical media as a series of digital pulses. If the network is Ethernet, the frame is broadcast to all nodes in the segment of the network. When the frame arrives at the destination, the process is reversed. As the data moves up the OSI model, each of the protocol frame formats is removed until the raw data is received at the highest level of the OSI model, the application layer. There are several methods for assigning IP addresses. The assignment of IP addresses falls into two broad categories. One is static, the other is dynamic. A static IP assignment means that an IP address is entered manually for each host on the network. This typically is done when the network interface card is configured. A dynamic IP assignment means that the IP address is issued automatically, typically when a computer boots and joins the network. Originally, computers on a network had to have their IP addresses assigned manually by static IP addressing. Static IP addressing is time-consuming, so Dynamic Host Configuration Protocol was designed to replace the manual setup. When a server runs DHCP, the IP addresses are assigned automatically. The act of automatically assigning IP addresses is known as dynamic addressing. The DHCP server has a pool or list of IP addresses to draw from. Every computer that logs onto a network is assigned an address from that pool. The IP address assignment is temporary. The address is released after a period of time and can be reissued to another computer. When a computer is booted, it automatically requests an IP address assignment from the DHCP server. The computer does not know where the server is, so it sends out that request as a broadcast to every node or host on the network. The protocol used for the request is UDP. The DHCP server receives the request and returns an unassigned IP address from its pool of IP addresses, which is also done in the form of a broadcast. The server returns the information as a UDP broadcast so that any other device connected to the same network will have the IP address information. The computer then accepts the assigned IP address and acknowledges this with another broadcast. This allows any other device, say a backup DHCP server, to update its database of IP address assignments. And then finally, the DHCP server acknowledges that the computer has accepted the IP address. It's important to note that when you're setting up a network using a DHCP server, you must assign static IP addresses to all servers and printers and any other equipment required to have static IP addresses. When the DHCP server assigns an IP address to a host, it does not necessarily assign the same IP address to the same piece of equipment every time. The IP address is randomly assigned. So therefore, for computers that need to be able to be consistently found, such as servers and printers, the devices have to have a static IP address assigned. The DHCP server sets a lease period for IP address assignments. The default lease period is 8 days, but the network administrator can modify this lease period. The length of the lease period depends on factors such as the type of network, the number of users, typical user profiles, and the available number of IP addresses assigned to the network. A special set of IP addresses have been set aside to use when DHCP cannot be reached. This range is 169.254.0.0 through 169.254.255.255. If a network interface card fails to find a DHCP server, if the card has not been set up with some sort of static IP address, then the workstation will automatically assign itself an IP address in the range 169.254 something dot something. This type of addressing is called automatic private IP addressing, a PIPA. And therefore, if two or more computers cannot find a DHCP, they set themselves to the same network, they can communicate with one another. We talked about ports very quickly recently. Port number is associated with TCP/IP protocol. It's used to create a virtual connection between two computers running TCP/IP. Computer, especially a server, runs many services at the same time. For example, server could coordinate many email requests, directory lookups, file transfers, internet search requests, or web page requests. Not for port numbers, the communications could get confused and errors would occur. Port numbers are assigned to network services. When the port number is combined with an IP address, it's referred to as a socket. The following is an example of a socket: 192.168.20.45:80. Notice that the IP address 192.168.20.45 is connected with a colon to port 80. There are basically port assignments. Of those include ports 20 and 21 for FTP, 22 for secure shell, 23 for telnet, 25 simple mail transfer protocol, 53 for DNS, 67 and 68 for DHCP traffic, port 80 for web traffic, HTTP, HTML, 110 for a POP3 mail service, 161 for SNMP, 443 for SSL, and on and on. There are some command prompt commands for troubleshooting. There's lots of problems that are typically associated with TCP/IP technology, and there are a number of utilities that help troubleshoot these problems. Netstat is one of these. The netstat command displays current TCP/IP and port statistics. It can be used to determine network problems such as excessive broadcasts on a network. It also allows the user to monitor network connections. The netstat-a command issued at the command prompt returns a list of services, port addresses, and the type of packets sent. The switch, or the A switch, is just one of the many switches available to use with netstat. Ping command is used to send a packet from one host to another on a network and then echo a reply in return. It is commonly used to quickly check the connection state of network media between two hosts on a network. The ping command can be used on LANs and WANs. To run the ping utility, you simply issue the ping command at the command prompt, followed by either an IP address or a host name that you wish to test communication between. Traceroute is spelled T-R-A-C-E-R-T. You can think of the traceroute utility as sort of an advanced ping. The traceroute utility sends a packet to a destination host, but it gathers statistics and information along the way, displays that information on the monitor. The final destination point echoes information such as who owns the site's domain name, the IP address, geographic location. Also displays every connection point along the route of the trace with information about its location. Most of the connection points displayed are going to be routers on the internet. A final command, Address Resolution Protocol, ARP, is used to map host MAC addresses to IP addresses. For a computer to be able to run ARP, ARP must know the computer's IP address. ARP is a protocol in the TCP/IP suite of protocols. Since it is dependent on TCP/IP, it needs to have an IP address assigned before it can reveal any information. ARP also caches information about contacts on the network. The ARP-A command issued on the command line lists all the IP addresses resolved to MAC addresses that your computer knows. And as always, remember, keep calm and document everything.